if I were to pick a favorite wedding reception song, I'd have to go, I think, with the electric slide. Slide to the left, slide to the right. And that is what we're about to do today here with phase shifts. See what I did there? Let's go. All righty. So we got our general forms once again. Boom. Most textbooks using that top one. Our textbook using the bottom one there. We're going to roll with it. Let's go. So first one. Graph the following function. Be sure to show the key points, right? Usually using 5 points in our sine and cosine functions here. Use the graph to identify the domain and range of the function. Cool. Awesome. So really it's what we've been doing, but now we're just going to be shifting left and right. Okay. So first off, our amplitude. You can see that it is 2. Awesome. Already off to a great start. Now, is there any kind of a period multiplier, right? That's the number that's in front of our x. No, there is not. So our period is just 2 pi like usual. Okay. So I can use that to scale it out, right? I'm going to do that off to the side here. 2 pi divided by 4. That's our normal pi over 2s that we're going to go by. So let me scale that out. All right, so the graph is nicely scaled here. It looks like we do also have a shift up of 1. So we'll need to adjust that with our midline there. Why don't I jot that midline on there with my fancy ruler? Whoop. Ah, I almost had it. There we go. And I'm going to go ahead and change the color of that midline. Let's see here. We'll go with a light green. So I like to jot down the midline because that reminds me of where I am like oscillating from, where I'm going up and down from. Now, normally my cosine function would start 1 above the midline. I'll use blue for my graph. But now since my amplitude is 2, I'm starting 2 above the midline. But also this plus pi over 2, I'm moving to the left pi over 2. So in my transformations area, how about I write down left pi divided by 2 and up 1, right? We did those 2 transformations, left pi over 2 and up 1. Awesome. So my point would then be starting right here. I start above the midline. I'm doing 2 above because of the amplitude. I shifted to the left, pi over 2. We're good to go. So now from there, I can use my cosine pattern. So it would be on the midline, then 2 below the midline, then back to the midline, and then above the midline. There we are. And now when I draw this in, there it is. I should have let it go because I did that first try. I was a little nervous, though. I was a little nervous. So we've got our cosine function, right? Make sure it curves back down. That's what happens with the cosine function because it's going to continue doing its thing here. And I could even go ahead and jot a little bit more down of this graph with maybe some dashes like, hey, it is going on forever. It is a periodic function, so it periodically repeats itself. Hence the name. And I could go like this all day long. I mean, I could never stop. And that's what's great about these is I could just keep on going and going and going. Okay, there we go. So one period is the solid, and then the rest of the dash that's just showing that it keeps on going there. Domain. Let's get into our domain now. Enough with the graph. My domain is all real numbers, right? Okay, so we could say from negative infinity to infinity for my domain. My range, the lowest it gets is -1, and the highest it gets is 3. So from -1, including it, to +3. There we are. First one out of the way, shifted it to the left, right? And not too bad. Not too bad at all. Cool. All right, for this next one here, you're going to notice that inside the parentheses, we have 3x minus pi. Now, in these 2 forms, this one right here, and then this one right here, notice how you have that factored aspect going on inside the sine function, or it could be a cosine function, but it's factored out. We need to do that before addressing our phase shift. So let's go ahead and factor out, and I'll change colors for this one so we don't get monotonous. We're going to have y equals 3 sine, and then I'm going to take the 3 out, leaving me with just x, and then minus, well, I would have pi over 3. That way, if I were to multiply it back in, it would go back to just minus pi. Okay? So now I'm in a form where I can analyze that phase shift, or that transformation, which would be to the right, pi divided by 3. There's nothing added outside, so there's no up and down movement. That would be our only transformation here. My amplitude, I can see that already, it's 3. My period, Well, normally it would be 2 pi, but because I had that multiplier of 3, 2 pi divided by 3, that's not even going to simplify, so it's just 2 pi divided by 3. Coolio. Ugh. That is an awful, awful phase shift. Or, sorry, awful period. But you know what? Maybe I shouldn't be so quick to judge, because perhaps with my transformations, it'll be okay. So let's start with it. Let's go. We've got to go ahead and divide that by 4, my period divided by 4 to get my tick marks, right? So if I were to divide it by 4 or multiply by 1/4, I'd end up getting 2 pi divided by 12, which would be pi divided by 6. So that's what I meant scaling by. Scale. All right, let's notch it out. All right, so we're all scaled out. Now, sine. Sine starts on the midline. In this case, it's still on the x-axis, right? And then, I'll go with a lighter blue. And we're shifting to the right pi over 3. So this scale, the period and the phase shift actually worked out pretty well with each other, which is nice. So we're going to the right pi over 3, which would put me right here. That would be my start, so to speak, of the sine function. Again, it goes on forever and ever and ever. So when we're talking about the start of it, it's just the start of our graph, not actually the start of the function, because it just continues on forever in each direction. Okay, awesome. So now I'm going to go above the midline, which would be 3 above because of my amplitude change, back down, and then 3 below, and then back up. So this would be 1 full period. Whew. I had to stop talking there to maintain focus. 1 full period of the sine function, and I can even backtrack it to with some dashed. And there we have it. So you can see all the other aspects of it. I just have 1 period of the function. Solid. All right, so my domain and range, once again, all real numbers for the domain, negative infinity to infinity. And for my range, I'm going as low as -3 and as high as +3. Awesome sauce. Fantastic. So far, I think so good. Hasn't been too terrifying. Oh, snap. What do we have going on here? Y plus 3 on the left-hand side? What are we crazy? When is that? Oh, wait. I can just use some basic algebra. I'm just going to go ahead and I'm going to subtract 3. Okay. Panic mode over. There's also the need to factor out a pi over 4. So we're going to have to do some stuff. Let me first put this down. Okay. Whew. Okay, first crisis averted. Now, to avert the second crisis. Why did I put +3? I don't know. That was ridiculous. Okay, that was a crisis and a half there, averted. Now, on to the other task at hand here. Factoring out that pi over 4. So we're going to have pi over 4, parentheses, x, plus. And if I'm ever like, well, if I divide by power of, wait, huh? What? Huh? Well, what is going to give me pi if I were to multiply that pi over 4 back in? Well, if I have a 4 here, if I were to distribute pi over 4 back into 4, the 4s would cancel, leaving me with pi, and yay, everything is back to normal. So I have factored this correctly. Now it's time to analyze, okay? Cool. You can also think of it as you're dividing by pi over 4, which is like multiplying by 4 over pi to that pi. So that would give you the 4 there is what I want when I'm dividing out that pi over 4. Okay. However you do it, as long as you get to that correct answer, we're good. Amplitude is 6, not -6, right? The negative is its own dealio, a reflection. Vertical reflection. Awesome. Period. Well, for period, I'm going to do 2 pi divided by pi over 4, which is like multiplying by 4 over pi. The pi's cancel, and I'm left with 8. So there's my period. So my scale is 8 divided by 4, which is 2. So I'm going to go by 2's here. 2, 4, 6, 8, 10, 12, 14, 16. Woo! -2, -4, -6, -8. Awesome. That was cool. That was fun. All righty. Anything else we need? Well, let's see here. That +4, that means we're going to the left. 4, and we're going down 3. And we have an amplitude of 6. So we got some scaling to do on the y-axis there. We'll go ahead and do that now. I'm thinking going by 3s might be useful. Let's see here. We can go 3, -3, -6, -9, and then +3, 6, +9. Okay, cool. That should give us enough room. Now, we went down 3, right? So my midline needs to be at -3. So start with that. We'll do a light sort of purplyish, more of like a plum, I would say. More of a plum. Okay, we got that. Now cosine starts on the midline. I'm going to go green. Get all the colors going. The cosine function usually starts above the midline, but because it was a reflection, it's going to be below the midline, 6 below the midline because of my amplitude. And we're going to the left 4. So that means I'm going to start right there. And when I say start, that's where we're starting our graph, right? That's not where the actual cosine graph starts because it doesn't really have a starting point. And now I can go up to the midline and then 6 above it and then back to the midline and then 6 below it. So that would be the 1 full period of our cosine function. And from here, I'm going to dash it out. Something just happened with this video where I paused and I didn't pause. I'm not sure. So just in case, we dashed out that graph there. You can see the solid green is 1 period, right? For 8 is your period length. And then we got the dash for the rest of it. Our domain was -infinity to +infinity. Our range is -9 to 3. Cool. Because it gets as low as -9 and as high as 3. And we got all of our transformations. I think we are good to go here. So we have a slightly different ask here in this one. Write the equation of a sine function that has the following characteristics in that form. Okay, so our form this is what's going to be asked of in our MyMathLab problems where it's multiplied out, not the factored form. Okay, but we're going to start with that factored form first. So I'm going to have f of x equals my amplitude of 4, so it's 4 sine. My period is pi. That means my period multiplier will. I would do 2 pi divided by pi. Remember, that's how the algebra always works out. So my multiplier is 2. My phase shift is 1/8. So I'm going to do that in factored form first. So if it's positive 1/8, that means it's 1/8 to the right. Let's say. So that'd be minus 1/8. There we go. And there's no shift up or down. All right, so what I'm going to do is now distribute this 2. Again, this is an 8 right there. Maybe I should just, there we go. That's a little clearer. Distribute it out. I get 4 sine. And then 2x minus 1/4. This is what MyMathLab would want if we're entering this in online. Boom. Nice. That was good stuff. So they do want it multiplied out. Make sure you do that when you're typing them in. And it will specifically say which form it wants it in. So it'll look like, hey, write it of this form. You can see that it's been factored out. It won't say this second part here. All right, so this is write the equations from the given graph in the form. Same thing we were doing before, right? Where we multiply it out. Cool. So we're going to start, though, with the factored form inside the sine and cosine functions. So for sine, remember, a sine starts on the midline, or in this case on the x-axis because that's where my midline is, and that would be my start of my sine function. We'll do this one in purple. So my sine goes from pi, and then it cruises on all the way over to 9 pi. Right? That's where it's back to that midline the second time. It's going to repeat itself now, right? Because it's going to keep on doing that kind of a thing. Okay. So 8 pi is my period. I don't know why I was going to write out pi. So 8 pi is the period. Coolio. I got to find my period multiplier. Well, 2 pi divided by 8 pi is 1/4. There's my period multiplier. All right. So right now I have y equals, I could get my amplitude as well. It looks like it's 3. So I'd have 3 sine, and then 1/4 for my multiplier. Now, do I shift it all? Yes, I shifted to the right pi. So that'd be minus pi. Did I move up and down at all? No. Thank goodness, because I'm out of room writing this thing. So now I need to distribute that 1/4, and I can write that as my final, which would be y equals 3 sine, parentheses, 1/4 x minus pi divided by 4. That's how it's going to be written in my math lab. So there we go. That's the first one. Now cosine, we'll go with cosine in, we'll say green. Now the start of my cosine function could be in any number of spots, but I'm going to start above. So that would mean that I have a shift to the right of 3 pi. So y equals, well, my amplitude's the same, but it's going to be cosine. My period is the same, so the period multiplier will be the same, but it will be a shift of 3 pi to the right. Second set. There we go. So now when I distribute the 1/4, I get 3 cosine 1/4 x minus 3 pi divided by 4. Close them. Dunzo. I like it. I like it a lot. Excellent. Fun stuff. Fantastic stuff. In fact, you could have shifted to the left pi, but then, like if I did this, I'll go with a light blue. If I did that one right there, I'd have y equals negative 3 cosine, and then it'd be 1/4 x, and it would have been plus pi, so plus pi over 4 for my final if I were to go that route, okay? So there's an infinite number of appropriate equations that we can have for either one of these. We just usually keep it close to the that y-axis, and also oftentimes shift in the same direction if needed. Totally up to you. Either one of those would have been acceptable. Cool? Awesome sauce. Fantastic. Wonderful. All right, last one here. Again, it's asking us to write it in that form where the omega's already been distributed through. So what we have here is we got to figure out our amplitude. Well, it looks like we have ourselves a midline of 1, so we're moving up 1. That's something important to write down. Up 1. Okay, just so I remember. Amplitude, it's getting 2 above and 2 below, so amplitude of 2. What's my period? Well, the period, let's see here. Looks like it's from, if we go from here to here, low spot to low spot, it's 3/2. So my period is 3/2, which means my period multiplier, that's the important one, 2 pi divided by 3/2, which is the same as 2 pi times 2/3. So that gives me 4 pi over 3. That's my period multiplier. All right. So with we'll do sine in red here. I'm going to start on the midline for sine. You could start there or you could start here. I'm going to start on the right just because I'm a positive kind of a guy, right? A positive kind of a person. So we get y equals 2 sine. I don't have to deal with the reflection then because it's going up first. That's another reason why I picked moving to the right rather than to the left. Because it's going to be a positive sine function and it's a moving to the right. I don't know why. All right, I don't know. That's my reasoning. I'm going to stop babbling about that. Okay, so then I have 4 pi divided by 3, and then x, and we're moving to the right. What are we moving to the right by? Well, if I am halfway between 0 and 3/4, that's going to be 3/8. So I subtract 3/8. Woo! Plus 1. This one's kind of messy. So y equals 2 sine 4 pi over 3x. And then when I distribute, those 3's would cancel out. Those 2 would cancel, right? And I'd be left with 4 pi over 8. And I can simplify that even further. 2 sine 4 pi divided by 3x minus pi over 2 plus 1. Whew! So there is my sine function. Now let's move on to cosine. I'll go with green on this one. You know what? No. I'm going to go with, I guess we'll stick with green. We'll go with green. All right, so I'm going to start down there, or I could start up top here. You know what? I guess for me, I'm going to go ahead. I'm going to go ahead and start up here again, because then there's no reflection with my cosine function. I'm just going to move to the right 3 pi over 4. I guess it's like either you do a reflection or you do a phase shift. It's your call. Okay? Let's write both. So for the green one, I would have y equals, and it's going to be, again, 2 cosine, and then we've got 4 pi divided by 3, parentheses x. Sorry, the music started playing there. Alrighty, so where were we? We're moving to the right 3/4, so divided by, minus 3/4, close, plus 1 still, right? We still have the same vertical shift. So let's go ahead and clean that up a little bit. 2 cosine. And then we have 4 pi over 3x. And then the 3's and the 4's are going to cancel, leaving me with just minus pi plus 1. But like I said, there is another option here, right? There is another option. We could go with the blue one that I have there, and I'll switch to that color. And that one would just have a reflection, right? So my reflection would be then y equals negative 2 cosine. My period is still the same. I don't know why I keep on doing weird things with the pi and the 4. 4 pi over 3x. There's no phase shift. Plus 1. I honestly think that one's a bit easier. I would take the reflection over the phase shift anytime. Your call, though. So there you go. There's 2 appropriate ones for you. But other than that, I mean, that's it. We Gucci, as they say. You guys have a wonderful, wonderful day. American freedom. Rock and roll. Costco. Stay hydrated. And follow Riverdog Jenny on the gram. See ya.